All right. Hello and welcome. So, what I have here is a retirement planning scenario broken down into three separate but somewhat interrelated parts. So, we're going to go through this sequentially, starting in part A. So, we're going to help a friend plan for retirement. They plan on retiring in 30 years from now. To do this, they're going to be investing $500 per month in a stock account and $500 per month in a bond account. So a balanced portfolio is split 50-50, but that will become imbalanced as returns accumulate because it'll be biased towards stock because stocks will earn 11% return and bonds are expected to return 7%. So when your friend retires, they plan on combining the money into an account that earns 7%. So, given this as background, your friend is wondering how much they can withdraw from the combined account each month, assuming a 25 year withdrawal period. So, there's basically two steps that we need to do in order to solve this. So, step one is to calculate the future value of both bonds and stocks, or the bond account and the stock account. So to do that, I'm going to insert a couple of rows here. I'm going to have one column for stock account and one for bond account. And I'm going to just go through this and look for variables that I need, time value of money related variables. So both are 30 years. They're going to start depositing now, and they want to know how much they can withdraw in their retirement, which is going to be in 30 years from now. I have this monthly payment amount here, which is 500 for both the stock account and 500 for the bond account. I have the expected return, which is 11% for stocks and 7% for bonds. And that is basically all I need to do this. I'm also going to add in a field called like payment frequency or payments per year. It's going to be 12. All right, so I have everything I need actually in order to calculate the future value now. So in Excel, that's FV. I have this rate, but I need to divide that by the payment frequency. So 11% divided by 12. My number of periods is the number of years multiplied by the payments per year, which is going to be 12. I have my payment. Here I'm going to do a negative 500. I'm investing money. That's an outflow to get a future value back. I'm assuming my present value is 0, so I'm going to ignore my my PV amount. So we have these now, like the combined portfolio amount here. That's step one. And I'm going to have to insert more rows. Obviously, I didn't plan this very well as far as spacing is concerned. Step two is now calculating how much they can withdraw. So here we have what each portion of their portfolio is going to be after the 30-year period. We're now wondering how much they can withdraw. So the present value is actually going to be the sum of these two numbers here. This is their combined portfolio present value. It might be a little bit confusing because here I said it was the FV, future value. That's true as of time 0. This is the value in 30 years from now. So now we're going forward 30 years from now, and we're saying this is how much we have. How much can we withdraw over a 25-year period? So again, I'll have similar variables now. I'll have years. So it's going to be 25. I was just checking to see withdrawals per year, whether it's monthly or annual withdrawals. So they're going to withdraw 12 times per year, once per month. We have a rate of return. They're going to continue earning interest on this $2 million, and they expect to earn 7%. And my future value is basically assumed to be 0. I'm going to put this here as a placeholder right now, but I'm going to ignore it. The question doesn't say include a margin of safety, but I'm going to just include it here as a variable. and put it to be 0. So now I'm going to calculate like the payment. The payment is going to be the withdrawal amount. So I have my rate, which is 7% divided by the withdrawals per year. I have my total number of periods, which is going to be 25 years multiplied by 12 for 12 withdrawals per year. My present value is basically this amount here, this 2 million, the combined amount, and my future value is assumed to be 0, so I'm not going to include it. I'm just going to see what this payment is. So I can withdraw $14 million. Now, what I should do probably is put this as a negative, perhaps, so that my withdrawal amount is a positive. This is just, I'm withdrawing this amount, so that's a positive inflow for me. So this is the amount here, 14,000 is with what they can withdraw. Now, I'm going to just propose here for a moment, like I'm going to validate this number, whether or not it's correct for a moment. And the way I'm going to do that is by building an amortization schedule for 25 years of this withdrawal amount. So I'm going to have payment beginning, payment amount, interest, ending. So for payment number 1, like withdrawal number 1, before they withdraw their very first payment, their portfolio is worth that $2 million. That's what this is referring to. Like before they do anything, how much do they have? They have this $2 million. Now I'm saying here that they're going to be withdrawing $14,000 per month, but they're going to continue to earn interest on this $2 million. So I'm going to say like the interest they're going to earn is equal to the amount of principal they have multiplied by the interest rate. And I'm going to lock that in with an absolute reference divided by the payment frequency. So here, if they began the period with this $2 million, they're going to be like withdrawing this 14,000, but they're still going to be earning this 11,000. So they're gonna end after the very first withdrawal like slightly lower because they're still earning interest. But all I need to do is basically this first two rows here, in order to, and I should have made this an absolute reference. In order to figure out like or visualize, the total impact here. So I'm going to just now 25 times 12. How many rows do I need? How many total periods are there? 300. I'm going to just copy paste this down to 300 rows, which will put me, I don't know exactly how many, 310. I forget what row I started on. I'll just go and see. So I was 9 short. So you can see after the 300th period in this schedule, if I'm withdrawing, maybe I won't say payment, maybe I'll say withdrawal amount. And this is going to be interest earned. So here, if I'm withdrawing, if I'm starting with $2 million in 12,000, and I'm withdrawing 14,000 per month, but still earning 7% on the original 2 million, that will last exactly 25 years. So you can see in the schedule how it operates per payment. In fact, at the ending balance here is like what's going to be left in that combined account after the 25 years. If I scroll to the very end, you can see this account has nothing. Now, when I was doing this, I alluded to like a margin of safety, and I didn't include this future value amount. So let me go back to my payment function, and I'm going to include this future value amount, which right now is 0, so it won't change anything. It's still 0 for my 300th payment. But like suppose I plan, like I don't know how much I'm going to need or how many years of retirement I actually need. Maybe I want to have a margin of safety of like 500,000, for example. If that's the case, it shifts my withdrawal amount. It's a little bit lower, but after the 25 years, I'm going to have like this 500,000 that's still in the account. So that's kind of what the future value here in this context is referring to. But that's not what the problem asked. The problem was assuming that the future value is 0. So what is the total payment? It's this 14,000. But you can just bake it into your formula and have it be dynamic, which is probably the best approach to do. So this is all of part A. Part A is done. Now, part B is a little bit different. And there's no good way for me to show where this is, given that I have this amortization schedule kind of mucking everything up. So let me move it. I'm going to move it over here. Now, part B recognizes that like the returns for stocks and bonds, they are uncertain. I mean, they're given in this problem at 11 and 7%, but realistically, no one really knows over a long period of time, particularly what stocks and bonds are going to earn. So here we're going to perform some sensitivity. We're going to create a 2-variable data table showing what the future value is going to be. So we calculated the future value to be like these two amounts here, based on like different return assumptions for both stocks and bonds. So the way I'm going to do this is I'm going to structure a 2-variable data table. So I'm going to have in a row here, I'm going to have the bond return, and in a column, I'm going to have the stock return. So the stocks, it tells me like I want to know what the future value is going to be for 7%, 8%, 9%, 10%, and so on. I'm just going to manually type this in. And I'm going to do the same thing for the bond returns: 4, 5, 6, 7, and 8. Okay. And maybe I'll just move this down 1 or 2 rows. All right, so now I want to figure out like what the future value is going to be if bonds return like 6% and stocks return 10%. What is this like combined amount right here? So I'll just label this a little bit differently. These are going to represent my bond returns here. So I'll just label these values before I move forward. Nothing fancy. But here I'm going to have a formula. For my formula, the intersection of my stock returns and bond returns, the upper left-hand corner here is going to be a formula. And what I'll do for my formula is just say like the future value of my stock component plus the future value of my bond component to get an amount here. And I get that like $2 million. But what I'm going to do now to create this 2-variable data table is select the extent of the table. Recognizing the upper left-hand corner, the intersection of my stock and bond returns, that is the future value of the combined portfolio after 30 years. I'm going to go to data on the ribbon, and now I'm going to go to what if, and I'm going to say data table. My row input cell, in the row here, I have my different bond return assumptions. I'm going to go to where I have that, which is right here. And the column here is my stock return assumption. So I'm going to select where that is an input. So both of these cells here are inputs into these two formulas, the output, and then these two formulas carry forward to be the upper left intersection here. So I'm going to click OK, and I'm going to get what my future value is going to be under those assumptions. So we can like spot check this to make sure that it is accurate. The way that we spot check is we just populate, or what are the assumptions now? 11 and 7. So with 11 and 7, you can see the intersection here is that 2,012,245, which is here, this. But let's just change the numbers to make sure. So at 5% bonds, 10% stocks, it's 1.546. 5% bonds, 10% stocks. I get that 1.546. So this output here is going to be the future value given different return assumptions. Now I'll just put this back to what it was for purposes of being consistent with the original problem, 11 and 7%. One final thing I'm going to do with this data table is this $2.2 million is somewhat confusing. I'd rather it be a label for the values that exist in the column. So the way to do that is I'm going to right click, and I'm realizing I'm probably sharing my screen in such a way that it won't allow you to see what I'm doing right now. But I clicked on right clicked on the cell, and I clicked on Format Cells from the menu that showed up. And under the Number tab, I'm going to Custom, and I'm typing stock return within quotations. And that allows me to show the stock or change what is displayed in the cell. It's still a formula here, but it just displays stock return as the label for these values, as opposed to the number, which was somewhat confusing. But there we have it. So this is a 2-variable data table showing what the future value is going to be, given different return related assumptions. So hopefully that all makes sense. All right, so there's one more component to this, part C. I haven't quite read that yet. Let me just go down and take a look. Your friend actually thinks they will require only $1 million in retirement. So that's basically way less than what these future values are evaluating to. Calculate the monthly deposit assuming they invest only in stocks. So that's part I. Part II is calculate the future value assuming they invest only in bonds, and then how much must the monthly deposit be assuming they invest 50% in stocks and 50% in bonds. All right, so I'm going to need to scroll up because my brain is a little bit too small to remember all of the variables that I need, so bear with me. I'm just going to copy paste this down here temporarily so I can kind of reference what I need. So the future value that they're working towards is now 1 million. They think they will only require this. My years is 30. They're going to be depositing 12 times per year. And just going to put this down one row. I'm going to do stock component first and bond, and then we'll just copy paste over. This is going to be the same for both I and II. Okay, so what else do I need? We have our expected return, R, which is 11% and 7%. And we're assuming that they have nothing right now. So what do we need to do? We need to calculate the monthly deposit required in order to meet this goal. So we can do that with the payment function. So equals PMT. I give it a rate, but divide that rate by the payment frequency. My number of periods, which is 30 years times 12 payments per year. And my present value amount is 0, and I'm working towards my goal, which is $1 million. So I would need to deposit as an outflow $356.57. So let's actually, before I move forward, just validate whether or not that makes sense. What we could do is, if we wanted to see it per payment, I could put this in an amortization schedule, and maybe what I'll do is I'm going to delete it in a moment. But I'll just copy and paste this here, and I start with $0. Here it's not withdrawal amount, it's deposit amount. I'm going to be depositing, in this case, $356 and 57 cents. The interest I earned is going to be this, the amount that I have saved, multiplied by the interest rate divided by the payment frequency. And then I'm gonna I started with that, I deposited this, and then I earned that. And that should be all I need in order to just copy paste this vertically. But how many periods do I need? Is it the same? Equals 30 times 12. I need 360 total payments. So I need to copy and paste this down. A couple more rows. 360. So you can see under these assumptions that it will accumulate to $1 million at the end of the 360th payment. So if I am depositing $356 per month into an account that is earning 11%, over 30 years, that will accumulate to $1 million. And you can just visually see that in an amortization schedule because the ending amount after the 360th payment is $1 million. But this is kind of taking it, maybe I will keep it down here just for purposes of sharing the spreadsheet. But I'm going to just move it down below a little bit because I need space, I think, to do what I need to do next. All right, so what am I doing next? Calculate the monthly deposit needed, assuming they invest 50% in stocks and 50% in bonds. All right, so this is part I in II right here. But part triple I and is a little bit different. Here we're going to be solving for the monthly deposit that's needed. We don't know what it is, but we do know how they're going to allocate it. It's going to be 50% stocks, 50% bonds. So here I'll have this like input is what I'm solving for. But the variables are basically the same. So let me copy and paste these assumptions down here. What I'm going to be doing now is the payment becomes this basically plus, or sorry, this times 50%. And for this one, the monthly payment becomes this times 50%. So if the result is like $500, my monthly payment is $250 because the monthly deposit is 50% stocks, 50% bonds. But I don't know what my monthly deposit is going to be. I'm going to just put this $500 here as a placeholder. What I'm going to be calculating, again, is this monthly deposit that I need, but I'm going to be using an additional tool to do that. I have a calculation here for my payment. Ultimately, I want to know what proportion of this is allocated to stocks and bonds. It's going to be 50% each, but I need to calculate the total future value, like what the monthly payment will accumulate to for each. So I'm going to have a future value function here where I have my rate divided by the payment frequency. I have my total number of periods, which is going to be the years multiplied by the months in the year. My payment amount, which I'll express as a negative, which for now I'm using this 500 as a placeholder. And I'm going to calculate a future value here and here. And it looks like this is actually some pretty close to what it would need to be. So I'm a little bit sad that my initial guess 500 was this close. So my total FV is these two amounts. So I want to know what monthly deposit will yield a total of exactly $1 million as my future value. So, I mean, I'm close enough where I could just play around with this number. It's going to be like 490. It's going to be like, oh gosh, I'm right there, which is a little bit too bad. But anyway, that's okay. Let's assume my initial guess was way off. Let's assume my initial guess was 300. All right. So the way I'm going to solve this is actually by going into goal seek. So I'm going to go to what if analysis and then goal seek. And I'm going to say I want to set this total FV value to my target, which is $1 million, by changing my monthly deposit amount here. And I'm just going to, so my target value is my total FV, which is the sum of my two FV functions that I have, one for stock and one for bond. And I'm going to set that to 1 million by changing my monthly deposit amount. So this is the input into my two payment functions. These two payment functions are an input into my two FV functions. And these two FV functions are basically the input into this total FV function. So it's all going to carry forward, and I can calculate exactly the monthly deposit that I would need under those assumptions using GoalSeek. So 496.96 will get me exactly there. Okay, so there we have it. The third and final component of this. I hope that you found it useful. If you have any questions, please feel free to reach out. Otherwise, take care, everyone.